Yo, what's going on, nerds and hackers? If you've stumbled across this video by accident, then hopefully you enjoy this. Otherwise, if you're here on purpose, I also hope you enjoy this too. So, I've put together like a proof of concept now for the system called integrity layer, or the skill, whatever you want to call it. And I want to demo that in this video. We can walk through how it works and what's going on, and we'll talk about the next steps, which is going to be profiling. How it works is we use the alt-syscall engine, which is obviously not kind of publicly available from Microsoft at the moment. So we're doing this all in undocumented APIs. So we hook system calls that us as the security vendor would want to monitor. Once we hook those, we basically suspend execution of the system call. So let's say you're going to open a process. Well, we're gonna intercept that within the kernel, and we're going to say, nope, I'm going to pause. So when that pause happens, we send a signal up to the EDR process, or whatever that looks like, that sits kind of up in user mode. That user mode security process can then interrogate the gubbins, the stuff that's going on underneath, to say, is this suspicious? So for example, if it's allocating some virtual memory, we might want to have a look at that and say, hey, does the or I should say, write in some virtual memory, does the bytes that are being written, do they match known signatures of shellcode, or Cobalt Strike, whatever it is. If everything's okay in the kind of fuzzy EDR logic section of this, then we can say, yep, you can continue execution. If the EDR goes, whoa, this is Metasploit, we can prevent the syscall from dispatching. We can contain the process. You can, do whatever the hell you want. So that's kind of the theory. So very quickly, we'll just walk through the code, how it works, and then we'll have a look at it in progress. Okay, so this is the user mode side. I think we'll only demonstrate this because it gets the point across without going through all of the code. This is obviously Rust. So the user mode and the driver are both built with Rust. So if you're interested in Rust driver development, let me know, because I might do a video series on how to do that. But anyway, the first thing we do is we run the engine, and we get a handle to the driver, which is, fairly normal stuff. What we then do is queue 1,000 events. So these are kind of IO events that go into the driver, and you can kind of think of them like, I like to sort of picture them in my head as like fishing lines. So these are kind of lines that we can put into the driver, and we pend these IO events. So rather than constantly polling the driver to say, hey, have you got an update? Hey, have you got an update? Hey, have you got an update? What we do instead is we just kind of dangle, for lack of a better phrase, these events down into the driver, and we mark them as pending. And there's a little subsystem. It's a cancel save queue that we go through to kind of keep these events around for the lifetime of the driver. So when the driver wants to complete one of these things, all we have to do is stick some data in it and basically flush it, and that goes straight back up to user mode. So we don't have to constantly poll the driver for updates. So it's quite efficient. And it allows us to dispatch the syscalls without waiting longer than we necessarily have to. So once we've queued those, we go into this loop here. And so we take those pending events, which contain like an object. So with this, we use the Rust ownership model to basically, in a loop, as long as we have events that are not yet completed, we will always loop. So we take the first event in the queue, and we check whether or not this event has been completed. So whether the kernel, or I should say, whether the driver has completed that particular IO request. So if it hasn't, again, in line with the ownership model, we push that item back into the queue, and that goes to the end, and it'll essentially go back to the beginning of the while loop, take the next thing from the front, so on and so forth until it's empty. Assuming, however, the driver has completed that particular event, then we grab the result from that. So it goes into this taken structure. This is kind of what we read out. And what we'll do in the user mode application is we'll print the received syscall, so the PID, the NT function that we hooked, and the UUID of the event. So the UUID we generate in the driver when we intercept the syscall. So it just gives us a unique identifier that we can then use to tell the driver or the kernel at that point, really, because we are in the throes of the syscall, that it can continue dispatch. So this, we check the function that we hooked. So in the event where it was NT open process, we have some encoded data that we return back inside of the enum. So in this case, we just simply send the PID back. Now, what we do is we print the fact that the process is trying to open a certain PID. We then open that process as, the EDR to inspect what it is. We then get the file path to the image that the process is trying to get a handle to, and we print that out to the screen. And we continue on by setting this result structure. So this we actually send back to the driver in an ioctl. So the driver is basically listening for this event coming down. And what we encode into here is a EDR result enum. So the first field that we have is the UUID. So this is the UUID of what came to us originally, and whether or not the EDR is allowing the syscall to continue. So taking the example from before, NT write virtual memory, maybe that buffer is malicious, maybe it's signatured, and we would want to say no, don't dispatch that. Otherwise, we of course say yes. So we prepare that and we send it back to the driver. The driver then uses that UUID to remove that from the queue and allows the syscall to complete and dispatch. If you want to see the full code for that, check it out on GitHub. I'll leave a link in the description. And with that, I think it's time to see this bad boy in action. So over here in the VM, we have calculator open. So we're going to use our test program to try and open a handled calculator. So the first thing we want to do is we want to start the driver. So we're in start.bat, and you can see start in skill driver. Nice. Next, we want to run the engine. So we want to say skill_engine.exe, and the engine has started, and all of those ioctls are now queued. Now we want to run skill test, and this is the PID of not Notepad, calculator. So when we run this, we should see all those response events happen here, and we should also see some prints in the debugger. So let's go and run the process and see what happens. Cool. So you can see here we've got loads of NT allocated virtual memories, which you'd expect. We've got the UUID over here of the event that we generated from the kernel. We've got the PID as well, and down here you can see hooked process is trying to open PID, so that's the foreign PID that we passed in up here, 10752, and we resolved the image to the executable, which of course in this case was calculator. And the driver then sends the result to the driver to release the syscall. We saw the ioctl in the code to release that, and then we can stop the driver just to show that we're not going to blue screen, or everything is neatly tied up. So we can say stop.bat, and there we go. I hope you enjoyed that. I've got some more things to do. I need to profile this. I'd love some feedback as well. So if you do want to see anything yourself, or you think you might use it in different ways, let me know. I am really curious as to how people use these tools. But until next time, see you later.